Hi, thanks for joining me. We are going to be talking about expected value in this video. So the expected value is the outcome that you can anticipate happening in the long run. So the key here is what will happen if you repeat something, some experiment or some event over and over and over again. So, for example, you might win if you sit down at a blackjack table the first hand. You might win the second hand. But eventually, if you look at the probability of winning or the expected value of each game that you play, the house has the advantage. If the expected value is negative, that means you're expected to lose in the long run. If the expected value is positive, then that means you're expected to win in the long run. So we're going to do two examples. The first example is if you're given information in a chart or a table. So the first, well, not necessarily the first, but one of the rows or columns, depending on how your chart is set up, will denote the probabilities, and the other one will denote the X's or the scores. So this is when you don't have equally likely outcomes. So you know that if you flip a coin, and it's a fair coin, that you have a 50% chance of flipping a heads and you have a 50% chance of flipping a tails. Well, in this example, you've got 4 different possible scores or 4 different possible X values, but they're not equally likely. You can see that there's the 35% chance of a score of 5, but there's only an 8% chance of a score of -7. So they're weighted differently. The way you take that into account is you multiply the probability by the appropriate score. So you're assuming, first of all, that these are all the possibilities. So if you add up all of the probabilities, you will see that they add up to 1. That's one key part. You're going to multiply the probability times the associated score. So you'll do 0.35 times 5, 0.08 times -7, 0.41 times 2, and 0.16 times 1. So when I multiply 0.35 times 5, I get 1.75. When I multiply 0.08 times a -7, I get a -0.56. When I multiply 0.41 times 2, I get 0.82. And when I multiply 0.16 times 1, I get 0.16. Once you multiply all the associated probabilities with their scores, you then add all of that up. So I'm going to add up all of those numbers that I just found. So 1.75 plus -0.56 plus 0.82 plus 0.16, and I get 2.17. This is the expected value in the long run. So since it's positive, it's a good thing, right? So if you're talking about money here, like let's say you could win $5 in the first case, you would lose $7 in the second case. You would win $2 in the third case, and you would win $1 in the fourth case. And they asked, do you want to play this game? Well, you find out that the expected value is positive. It's a positive $2.17. So that means on average, in the long run, you will win about $2.17 per game. So as long as it's not like play once, you can play as many times as you'd like, it's a great idea to play the game. If you would have gotten a negative $2.17, then you would say you would not want to play the game because that means you're expected, on average, in the long run, to lose that money. All right, let's look at the next example. So this is one where they're giving you a little application problem, no table. Let's read it and see if we can figure out what to do. So the high school PTO is trying to raise money for the school by sponsoring a casino night. They design a game in which they have a bag of 500 tickets to choose from. 1 gold, 2 silver, 3 bronze, and the rest are black. They charge $10 to draw 1 ticket. If a gold ticket is drawn, the player wins $1,000. If a silver ticket is drawn, the player wins $500. If a bronze ticket is drawn, the player wins $250. If a black ticket is drawn, the player wins nothing. So in other words, they paid $10 and then they don't get anything in return. What is the player's expected value for this game? So first, it wasn't clear if you draw a ticket, does that ticket go back in the bag or not? So we're going to assume that whatever ticket you draw, it goes back in the bag. So each person gets to take a ticket and then they replace it and the bag is mixed up and then the next person comes up, so they have the same number of tickets, 500, to choose from. It would be totally different if it was not replaced. So if someone drew a black ticket and then that black ticket wasn't replaced, that means the next person would have a better chance of winning a prize, right? So this, we're going to assume the ticket is replaced. So let's first clear that up. Ticket is replaced after each draw. Okay, so part A, what is the player's expected value for this game? So the first thing you need to remember is that you're paying $10 to draw a ticket. So let's look at the probabilities and the options of winning. Okay, so how can you win? What are your expected outcomes? That's going to be X. And then what's the probability of that happening? Okay, so one option is you draw a gold ticket. So let's see. Gold ticket. And actually, let's see, the event. And X can be the amount of money you will win, right? So one thing that can happen is that you draw the gold ticket. There's one gold ticket out of 500 tickets. So the probability of that happening is 1 out of 500. The amount of money you'll win if you draw a gold ticket is $1,000. But remember that you paid $10 to play. So your kind of net profit there will be $990. So they still have the $10 you gave them, and then they'll give you $1,000. So you're earning $990. The next option is you could draw a silver ticket. There are 2 silver tickets out of 500. So that's the probability of drawing a silver ticket. And if you get a silver ticket, you win $500. Again, you paid $10 to play, so your net profit will be $490. All right, a third possibility is you draw a bronze ticket. If you draw a bronze ticket, you will win, let's see, $250. You paid $10 to play, so your net profit will be $240. And there are 3 bronze tickets. So 3 out of 500 would be the probability for that. And then last, there are a bunch of black tickets, right? And if you get a black ticket, you win nothing. So it's a negative $10 because you paid $10 to play and then you don't win anything. So that's a negative $10 for the player. And then let's see how many black tickets there are. So far we've used 1 gold, 2 silver, and 3 bronze. So if we add that up, we can see that that's 6. If there are a total of 500 tickets and we used 6, that leaves 494 tickets that are black. So 494 out of 500 is your probability for drawing a black ticket. Okay, so if you add up all of your numerators, they should add up to 500, and they do. That means all of the options are listed here in the chart. So now to find the expected value, we multiply the value of the event times the probability of that event happening. So 1 out of 500, so 1 divided by 500 is 0.002. and then we multiply that by $990. And the expected value is 198, a positive. Okay. Then we do 2 divided by 500, and that's 0.004, and we multiply that by $490, and that expected value is 196. Now we do 3 divided by 500, and that's 0.006. We multiply that by the $240, and we get an expected value of $1.44. And then last, we have 494 divided by 500, and that's 0.988. And we multiply that by a negative $10. And we see that the expected value is negative $9.88. So to find the overall expected value, we add all of those up. So I'm kind of out of space here, but let me use blue. So we're going to add all these up. So 198 plus 196 plus 144 minus 988, and that gives an expected value of negative $4.50. So from the player's perspective, you may not want to play, because in the long run you're going to lose $4.50. So it might not make sense to stand there and play over and over and over again, because you're going to end up losing $4.50. But there are other reasons to play the game. So maybe you want to support the PTO and take a chance and you spend $10 one time. Maybe you win, probably you don't. But that's how you find the expected value of the game. So this would be a good game for the high school PTO to offer, right? Because if the player is expected to lose, that means that the high school PTO is expected to win, right, in the long run. So part B is asking that, will the high school PTO make money on this game? And the answer is probably so. And you can't say for sure, because what happens if only one person decides to play this game and that one person happens to draw the gold ticket? Well, then the PTO has lost $990. So not good. But if they know that they're going to be able to get a lot of people to play this game, then they're expected to win in the long run.